Okay, we're going to be talking about section 3.2.1, curve fitting, and then in the end, fractional exponents. So it's got a little bit of review still. In the equation y equals mx plus b, which letters represent the variables? Now our variables are still x and y. Our parameters, our rules for this are going to be the m and the b, the slope and the y-intercept. The parameters are going to be constant. Now our variables are going to change depending on where we are in the graph. So now for problem number 2, it says write an equation of a line with a slope of 3 passing through the point 519. So we know y equals mx plus b, and we need to find the b. This is our x and our y. So 19 equals 3 times x, which is 5, plus b. 19 equals 15 plus b. Subtract 15 from both sides. 4 equals b. So our equation, y equals 3x plus 4. There's the equation of our line. Now, for exponential, y equals a times b to the x, once again, our variables are x and y. Our parameters, our rules, are a and b. Once again, variables, they'll change. The parameters for those equations are always going to be the same. They're going to be constant. So we're going to write the equation here for this given exponential function. Now, what we can do is we can solve for this. Now we know y equals a times b to the x. Now we have the point 0, 7, and we have the other point 3 and 56. Now there's a way for us to solve for this algebraically. 0, 7, so we know a is 7. So I'm going to use the other point. 56 equals a, which is 7, times b to the x, which is 3. I can divide both sides by 7. 56 divided by 7 is 8, and that equals b to the third. And then we can take the cube root of both sides. So b equals, and the cube root of 8 is 2. We've got our parameters. So y equals 7 times 2 to the x. There is our exponential function. Let's go to the next page. We're going to write another exponential function. And it's telling us that our asymptote's at y equals 0. Now that's going to have some effect on us later in the year, but not right now. So once again, they're in the form of y equals a times b to the x. A, our initial, is our y-intercept. A, given that 0.05, is 5. We need to find b. So using this point, that's our x and our y. 320 equals a, which is 5, b we don't know, to the third power. Divide both sides by 5. 64 equals b to the third. To solve for b, take the cube root of both sides. b equals, and the cube root of 64 is 4. So y equals a, which is 5, b we found is 4 to the x. There's our exponential function. Now we have some new notation for roots. X to the a over b. That's the b root of x to the a. Now, when we have these rational exponents, a is the power. Whatever power we're raising to, the denominator b is the root. Now, we've seen negative exponents before. Remember, negative exponent means reciprocal. If it's on top, it moves to the bottom. If it's on the bottom, it moves to the top. So what we can do is we can take these and take them from this rational exponent and write it in radical form. So we're taking the third root. So we have underneath this, it's a cube root, so we have this, looks like a radical. Put a little 3 there. That's called the index. And then we could have 10. And the whole thing could be squared. You could write it like that. Or it's the cube root of 10 squared, which would be the same as the cube root of 100. That's 3 different ways to write the same thing. Now for part B, we can write this as the cube root of 9 to the 4th, which is the same as the cube root of 6,561. We can also write it with rational exponents. 9, 4 is the power, and the root is 3, so 9 to the 4 thirds. For part C, we can write it as the 5th root of x, all being raised to the 3rd power, or with rational exponents, x, 3 goes on top, and because we're taking the 5th root, the 5 goes on the bottom. Now, for part D, square root, there's actually a little 2 there that we don't write. So what we could do is we could write this as the square root of 2 to the 5th, which is the square root of 32, or with rational exponents, 2, 5 halves, because we're taking the square root, so the 2 goes in the denominator. For E, the square root of 5, all being raised to the 7th power, or the square root of 5 to the 7th, which is the same as the square root of 78,125. Now, 3 divided by 3 is 1. So you could write it as y to the 1st, which is just y, or the cube root of y cubed. And when you cube a cube root, you're just going to get y as well. For G, the denominator is a 2, so it's the square root. So it's the square root of 16, all being raised to the 3rd power, or the square root of 16 cubed, which is the same as, sorry, let me do that one more time. The square root of 16, which is 4 cubed, which is 64. So there's another way to write it. 8 to the negative 4 thirds. We're going to write that as 1 over 8 to the 4 thirds. So that's going to be 1 over the cube root of 8, all being raised to the 4th. Now, the cube root of 8 is 2. It's the same as 1 over 2 to the 4th, which is 1 over 16. There's another way to write it. Or you could write it as 1 over the cube root of 8 to the 4th. A couple of different ways to write this. And for I, 1 over, to begin, 1 over 32 to the positive 3/5, which is 1 over the cube root of 32, all being raised to the 5th. Now the cube root of 32, I'm sorry, that's the 5th root cubed. Now the 5th root of 32 is 2, so it's the same as 1 over 2 cubed, which is 1 over 8. You could also write it as 1 over the 5th root of 32 cubed. Multiple ways to write that. And those are rational exponents. The thing to remember about rational exponents, the numerator is the power, the exponent, and b is the root. All right, see you in the next section.